Algebra 1 Common Core, Unit 2, Section 5, Multiplying and Dividing Radical Expressions. First of all, I want to apologize if this video is sounding or looking a little bit differently than the other videos you've watched in my series. I'm using a different computer and a different recording tool here, so it's kind of an experiment in its own way, but let's give it a shot. So the last video was on adding and subtracting and simplifying radical expressions, and that's really the key thing here. The most important thing you can be able to do with radicals is to know how to simplify them. You know, everything we see sees simplest radical form. And that's really important to have that. And so we know that for simplifying them, you know, of course that's it. And then when we're adding and subtracting, we can only combine radicals if they have the same like radical. So they need to be in simplest radical form to determine if they are like radicals, and then so on. You know, for example, if we had, rad 20 plus rad 45, you had to first simplify rad 20 down to 2 rad 5 and rad 45 down to 3 rad 5 before you could add them together, and the result was 5 rad 5. So, see, I'm getting these weird little boxes here, so still figuring out this new program here. But notice that, you know, I couldn't add these two radicals together because rad 20 and rad 45 were not like radicals, but once they both became rad 5, I could add them together, and then it stayed rad 5. All I added was the outside, and I was able to do that because they then had like radicals. You know, addition and subtraction are very like term dependent. We see, you know, for fractions, we need common denominators. For variables, we need the same exponent and the same variable. And for radicals, we need the same radicals. Multiplication and division don't care about like terms. You know, you can multiply unlike fractions, like, you know, 2/3 and 4/5. You can't add those fractions the way they are now. You'd have to get common denominators of both over 15 to add them together. But you can multiply them, and you just multiply across the top and multiply across the bottom, be 8 over 15. You know, so multiplication isn't so picky about like terms. And the same thing for radicals. You know, like you can multiply two, like this example here, rad 5 and rad 8. They are not like radicals. And even if you reduce rad 8, they're not going to be like radicals. So you would not be able to add or subtract them together, but you can multiply them. And to multiply radicals is very similar to multiplying fractions. Like you multiply across the top and you multiply across the bottom. Well, when you multiply radicals, you multiply the inside parts and then you multiply the outside parts. So this was 2 times 3, 6 out front, 5 times 8, 40 inside. Then you simplify into simplest radical form like we've been doing. So it's really just another exercise in simplifying radicals. All right, so let's look at a couple of examples here. Rad 2 times rad 8. Now, I can reduce rad 8, but I recommend when it comes to multiplying and dividing to multiply first. So let's do rad 2 times rad 8. You can do is rad 2 times 8 comes out to be rad 16. Now, you want to reduce rad 16 like normal. Now, this is one of those cases where the radical turns out to be rational because the number inside is square. Remember, you got to be very easy to recognize your list of squares. Let me throw that list over here. 1 times 1 is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. And the list goes on. But 16, we see, is on our list. So the square root of 16 is just 4. That's the final answer. Here's another one. Rad 3 times rad 8. Well, 3 times 8 is 24. Now, 24 is not on the list, but it can be divided by 4. So we split it up into rad 4 times rad 6. Remember, the one that square goes on the left, and I like to circle the square. And the square root of 4 is 2, so that comes outside. You know, the two numbers that multiply to 24, one of them has to be a square from your list of squares. And the square root of that number is what goes outside. The one that's not square, 6, that stays inside your radical 2 rad 6. That's your final answer for that one. So another one, 4 rad 5 times 2 rad 10. Again, you multiply the numbers outside. So we're going to do 4 times 2 on the outside, and the inside 5 times 10. 4 times 2, of course, is 8. 5 times 10 is 50. 50 is not on the list, but it can be divided by 25. So the square root of 25 times the square root of 2. These together multiply to 50. Circle the square. The square root of 25 is 5. The rad 2 stays inside. Now you already had an 8 outside. The number outside, the new number outside, they are multiplied. Don't forget to multiply those. And 5 times 8, of course, is 40. So 40 rad 2 is our answer there. All right, let's keep going. Now, what about a radical squared? Well, remember, something squared is simply times itself. So rad 5 squared is just rad 5 times rad 5. And rad 5 times rad 5 is rad 25. And 25 is on your list. Oops, there's a little bit too much there. It is rad 25. And the square root of 25 is just 5. Because that's a square. And you kind of see that happen when you do a square root squared. You mean square root and square root are kind of opposite inverse operations of each other. It's like plus 2 minus 2, times 2 divide 2. So square something, square root it. You get back to where you were. So square rooting 5 and then squaring it, you're just going to be back with 5. Now 4 rad 3 squared, again, you're not just going to be 4 and 3. Again, the easiest way to approach it is to think times itself. So 4 rad 3 times 4 rad 3. Outside 4 times 4 is 16. The inside, 3 times 3 is 9. But then whenever you're squaring a radical, you're going to get a rational, one that's from your list of squares. And so that just comes out to be 3. And 16 times 3 may need a little calculator help, but it comes out to be 48. Division's the same way. No different than multiplication. Instead of multiplying the outside and inside, we're going to divide the outside and divide the inside. So 15 divided by 3 is 5. 24 divided by 2 is 12. Rad 12 is 4 times 3. Square root of 4 is 2. So 2 rad 3 times the number already out front. I end up with 10 rad 3. Last one. 8 divided by 2 is 4. And 20 divided by 5 is 4. And 4 is from your list of squares. So the square root of 4 is 2. And 4 times 2, a final answer 8. So remember, if your final radical ends up with a square, that means it's rational, and you will get a no radical solution. And so that does happen from time to time. All right, guys, so that's multiplying and dividing radical expressions. We'll continue to practice this in class.